Nutrient availability and efficiency. Is your plant able to see everything that's out there? And is it available? And is it using it efficiency? Again, cycling with your biological activity, somewhat related to your organic matter. And then water infiltration, retention, percolation. Something to think about on water as well. Common challenges and struggles that we see on a weekly basis, that we get phone calls about. Soil compaction. That's related to carbon and oxygen. Your erosion is a breakdown of structure. It's not resilient and resistant to forces outside of our control. Wind. Nebraska can get the wind right. Downpours, Mother Nature doing what she does best. That's a breakdown of your soil structure. Nutrient depletion. Is it truly depleted, or is it just not available and plant available? Something to think about. We see a lot of increased pests and disease pressure, particularly the last 5 to 10 years. Different diseases, different pests that I didn't worry about or didn't pay attention to 15, 20 years ago. We've all got super weeds, right? Yeah. Super weeds are an indication of something else going on. They're a symptom. Dandelions? Anybody? Anybody got dandelions? We kind of hate dandelions. They're just kind of annoying. Low calcium, high potassium, high chloride is what dandelions are telling us. Low humus, compaction. Dandelions they'll root down to 3 foot. And they're trying to bring up calcium from your lower profile. Dandelions aren't all bad. I have a whole book, When Weeds Talk. So if you got a weed problem, let's figure it out what you got going on here. Palmer amaranth, water hemp, anything like that. It's telling us we've got something going on. Increased competition. In a balanced system, there is no competition. So, little Soil Science 101 for our college student over in the corner. Let's see if this is any of your classes that you've got. Okay, we all know physical properties, right? You got soil aggregation, tilth. When you've got good soil aggregation and you've got that infiltration and good root activity, no compaction layers, everything's rolling. We like a chocolate cake, right? Said chocolate cake, you kind of know what chocolate cake looks like when it's crumbly. That's good soil tilth. Those aggregates are pieces of other soil particles in biology, and then you get bigger. So you got microscopic is your sand and your gravel and your clay and that kind of stuff, and then you get much of those. Now you've got more surface area, so then you can hold more oxygen, you can hold more water. Adequate, which leads into adequate water infiltration and retention, and then that resistance and resilience to erosion. We're probably not going to 100% resist erosion. You got multiple days of wind upon wind upon wind, so things are moving, but can our soils be resilient and build back up faster than before with a balanced system? You got your chemical. Of course, we all know and have heard about and are familiar and concerned with pH and your calcium levels. That's a chemical side of things. You want sufficient nutrient cycling and nutrients that are plant available. Of course, we want minimal pollutant contact. We're not here to say don't use herbicides, fungicides, insecticides. They're a tool in the toolbox and they all have a necessary purpose. Are there ways that we can help buffer some of those things with other products that are beneficial for the soil biology or for soil structure and things like that? Can we kind of not make them as harsh on that thing? Can we make them more efficient on the weeds that we've got or the whatever issue, struggle that we've got there? What kind of things do we need to look at there? Plant available carbon. You guys know how much carbon you have that's plant available in your soils? Everybody hears about carbon markets, right? Carbon sequestration and carbon's killing the earth. We need carbon. Plants, absolutely. Soil biology, soils need carbon. And then you need to start balance. Again, your soil craves balance on and in the chemical side of things. Everything's about balance. Biological then. We want rich diversity, so earthworms, bacteria, fungi, protozoa, good nematodes. You want a few bad guys for the good guys to eat. You've got crickets and spiders that are tearing up trash and everything. Like you want that rich diversity of biology. Of course, high levels of organic matter. We all want organic matter. We know the value of organic matter. And something that's really cool, did you know plants have fat content? Yeah. So, high fat content plants have high energy levels. High nitrogen and K leads to, so high nitrogen and high potassium levels lead to low fat within your plants. How do we achieve high fat? Good and efficient photosynthesis. That leads carbs created by photosynthesis to go to biology, and then the lipids, et cetera, from biology are stored as energy in the plant as fat. An indicator of high fat plants, leaves are shiny. High lipids come from high sulfur. A rule of thumb, 1 pound of sulfur per inch of annual rainfall. But then watch your nitrogen to sulfur ratios because we need to maintain a balanced carbon to nitrogen ratio, which we'll get into in a little bit. So fat content is huge on the biology side of things. And that's part of trash decomp and cycling as well. Mind's blown yet? If you go into the mind blown of your plants are literally eating biology, but that's a whole nother discussion. So, we've seen the soil food web before, or some version of it. You've got 5 levels, 5 trophic levels. I'm not going to go hardcore because I'm still trying to wrap my head around it. There are very in-depth courses that a person can take. If anything like this intrigues you, I can send you resources. But you've got your first level, and that's your photosynthesis and your relationship with your plants, roots, the exudates, and the biology there. Second level, you get into decomposers, mutualists, and pathogens and parasites. I wish I had a pointer, but it falls in vertically like that. So bacteria, fungi, and root feeder nematodes are second level. Then you get into third level, which is your shredders, your predators, and your grazers. So protozoa, fungal, and bacterial feeding nematodes. And then arthropods, which are some of your shredders. Spiders will tear trash. You want spiders in your fields, but not spider mites. Not to be confused there in corn particularly. Fourth level is your higher end predators, so literally nematodes that are eating other nematodes. They're not your root feeder ones, those are the bad guys, but you have good nematodes out there. Your bigger arthropods, so crickets, beetles, and then of course your animals, birds, for your fifth level. Soil biology is about the flow of energy, which is the sunlight through the system. Energy, sunlight is your energy. Exudates out the roots that signal to certain bacteria and fungi that it needs or wants a specific nutrient to start the enzyme process. Then nutrients will be stored in your bacteria and your fungi. And that's where we want those nutrients. That's where they are most safe. Organisms control your chemistry. We'll touch on that on the pH side a little bit. And then we think about aerobic versus anaerobic conditions, which of course has to do with oxygen, good levels or low levels, so high levels or low. Our nodules on our soybeans, those nodules are actually anaerobic inside because that particular nitrogen fixing bacteria does not want and does not like oxygen. So those little nodules are like a little cocoon, and that's the relationship and the activity that's going on with any of your legumes. So not just soybeans, so all of your legumes with the nodulation. So anaerobic and aerobic, we want some anaerobic in certain situations. Most of the time we think of anaerobic as a fully saturated soil that stinks and isn't very friendly, and then like if you get into the manure and the lagoon part of things, and yeah, but fun little fact on legume nodules, those nodules are anaerobic inside. So pretty cool. And because we want the nutrients stored in the bacteria, when those nodules break down in the off season, thus for most likely corn, the next crop, that's pretty much what everybody does, right? After soybeans is a grass crop, corn, millet, whatever. That's the nitrogen that your plants are taking up, is that bacteria from those nodules that had that nitrogen. Oh, it's so cool. It's so cool. I'm nerding out. It's been 3 weeks of nerding out. 3 years of nerding out, sorry. Not one part of soil biology that I think a lot of people don't know and or don't understand, mycorrhizal fungi. Has everybody heard of that to a point? A couple people have. I know a couple people over here have for sure. Yeah, mycorrhizal fungi. This organism should become your new best friend because it dictates so much of what's going on out there. It is the highway and the internet in your soils. So your transportation of literally physical things, nutrients, water, and the information attached with all of that. It is single cell, which is weird to think about. It's in and on the roots, increasing root reach tenfold. So if you got roots only, say, 10 inches deep, now you can get it 10 inches or 10 times around with that mycorrhizal fungi network. So, you know, in essence, 100. Whatever that's bigger than my arm span. But miles and miles of network. It's that relationship between your colonies of bacteria and biology and the plant roots. It is believed to be quantum. We listened to a couple of guys last December of 23 talk about mycorrhizal fungi for quite a while, and they brought up that somebody somewhere had way more time, brain power, and dollars than any of us have combined. And they did a study of how they could affect mycorrhizal fungi, and that's how they determined it was quantum, in that something happened here and 10 miles away it was affected, something else, because of that network and that mile. So what your neighbor does affects you, what you do affects your neighbor. Ruh-roh, Shaggy. Or Zach corrected me, ruh-roh, Raggy. So, quantum. Didn't know you were going to be physicists, right? Mycorrhizal fungi helps transport everything to the plant. Your water, your nitrogen, your phosphorus, which is immobile, potassium, sulfur, zinc, which is immobile, magnesium, boron, all the things. 80% of your phos to the plant comes from mycorrhizal fungi. 25% of your zinc, 60% of your copper. Plant-to-plant communication, if a bug chews on this plant, grasshopper, aphid, whatever, that signals out through, I have been bitten by something. I need defense. I need the fire department to come my way. That mycorrhizal fungi sends that signal to the surrounding plants through the network. The other plants can start developing a defense system against those bugs. Same with diseases. It's plant-to-plant communication. Ways we sometimes destroy it or damage it. Tillage, constant use of phosphorus fertilizers, no matter what kind of phos, if it's 1034O, MAP. Most of the time it's about the only two that most people use around here. If we deplete or decrease our soil organic matter, herbicides and pesticides can affect it. We did learn the other night from a podcast that they have shown that your fungicide on your corn seed treatment doesn't affect mycorrhizal fungi, which is kind of interesting. You should think a fungicide would go after a fungus, but it must be a little smarter than that. Ways to increase it: crop diversity, rotation, which everybody's got some type of rotation in there, which is good. If we can get more diversity in there, that's great. And you can also inoculate. There are different products out there where you can do a seed treatment and inoculate mycorrhizal fungi. I think we're gonna we have some plans, yes, to trial one or two of those kind of products this year. How we're gonna measure mycorrhizal fungi, I have no idea. We haven't crossed that bridge yet, but we'll keep you posted. Moving on to photosynthesis. We can remember clear back from high school science. Your plant draws up water. Leaves take in carbon, leaves trap energy from the sunlight. That plant uses that energy to turn water and carbon into sugars and oxygen, releases the oxygen, sends the sugars out through the roots. That's the root exudates that anytime I mention that, that's this process. It's those sugars, that glucose. So, have you ever been called a light farmer? You have millions and millions of solar panels out there. It's that creation of that sugar, which is energy, and it cannot move. We want happy plants. Unfortunately, they're not happy all of the time, all of their life. Cloudy days aren't super exciting. We got smoke in the air, solar radiation, that kind of thing. If the plant is stressed and shut down, you don't have proper photosynthesis going on. A little side note into photosynthesis and nitrogen. Roughly 15 to 30% of sugars created by those plants every day is spent to convert nitrate to a protein, and then 50% to convert ammonium to a protein. That's a lot of sugar needed just for the conversion of a nutrient to a form that the plant truly wants. The sugars activate the enzymes that happen. So without them, or without adequate number of sugar, adequate quantity of sugar, you don't complete that protein process, and we add stress. Back on the nitrate/ammonium side, meaning the plant did not take up the protein form, they literally took up the nitrate or the ammonium. You plug up the system, and that draws in bugs and diseases. So, two things for complete photosynthesis. The quantity of the volume is increasing, preferably double every 24-hour period, but increasing is increasing, so we'll take it, because we know it's not going to double. There's just so many factors that go into that. And then the production of that complete carb process, the quality of that photosynthesis and that sugar conversion process. So going back to, you plug up the system in corn with too much nitrate or ammonium uptake in the plant, you bring on bugs and diseases. A thing to pay attention to is if your corn plant throws out new brace roots. So it goes up a node and then throws out another set of brace roots. It's not because it's thinking that it needs to stabilize itself. It's trying to get rid of nitrate or ammonium. It's looking for a way. Everybody had a night where you drank too much? Yeah. Maybe the next morning somebody said, oh man, you kind of stink. Your pores, your body's looking for any way to get rid of that toxin. It's the same thing with plants. They all have signs. The corn is the one that we pay attention to the most. Are we throwing out another set of brace roots? So, There is a way to test this. It's not a perfect science, but it is with a little tool called a refractometer. We have a couple of them. We haven't used them as much as we should, just because we kind of forget about them and whatnot, but for bricks testing. We will be doing a lot more of that more frequently for everybody that we're working with. We're out there checking seed, or you've got us hired for scouting. We will be incorporating that information more often on sheets, and we'll be using this kind of scale. This is, I don't think there's many of them out there. This is the first one that I found when I did my search, but that's what we're looking for. We want those high numbers. You've got a good sugars in that plant. That's photosynthesizing like it should. Again, it's not scientific, but it's a good indicator of things going on. So we'll be incorporating that. Moving into soil structure and porosity, carbon is needed for soil structure and structure creation. It's all about creating that structure and then keeping it. A loss of carbon will get you compaction. Absolutely critical for water infiltration and retention, going back to percolation as well. And then how do we get aggregation? So aggregation, as I mentioned earlier, the clumps of soil formed by the physical, chemical, and biological activity. A great deal of biological activity takes place within each one of those aggregates. And then they're connected to the plant roots. So a fun little thing to do, and this works for garden, flower plants, corn, beans, whatever, is go out there, dig around the plant as much root as possible, and then shake it loose, and whatever soil is stuck on the roots is giving you an indication that there is that glomalin, that glue, which is a form of mycorrhizal fungi, by the way, that you've got root exudates happening, and you've got the start of aggregation happening. You can lightly grab a hold of that root and kind of pull that soil particle off to see the white root then. That's a good sign. You got something going on the good side of things. As much green and growing during the year as you can get. Back to anaerobic versus aerobic, definitely related to soil porosity and soil structure. Again, that oxygen present versus none, and then and that nitrogen cycle, parts of the nitrogen cycle, such as the legume side of it, it has to do with the reduction of oxide with iron and manganese through the reduced phase. It's pretty intense, but certain times and places we want an anaerobic condition, but not across the whole field all the time. So, is your soil like tile, or is it like chocolate cake? Flooring, layers of tile, or layers of other junk. We've had that experience with our house projects. It would have been way easier to remove chocolate cake to get down to the layer that we wanted. But we had tile and tile and tile. So we had major compaction in our house for a good example there. I got a YouTube video and it wouldn't let me connect to the internet, so it's not gonna work. If anybody's interested in the video, it's only like a 3 to 4 minute video, and we have the tools to do it. It's pretty simple. You just need screens like this. Take your soil, lightly crumble it, and that's what they do in the video, is they take 2 different kinds of soil, lightly crumble it into this, and then put that in a bowl or something and let it get it fully saturated. And then take your 2 samples, flip them over, pull them up, and then observe and see how that clump stays together after you remove the screen. Does it kind of get like a mud pie and kind of flow out and get really shiny, or does it stay more formed? Does it look a little bit more like chocolate cake? When that's going to give you a good indication of what kind of aggregation you have. If you would like us to do that, we'll be doing that just for kicks and giggles for ourselves, but if you're curious for yourself and want to go with us, it's not a very long 5-minute process. So we can do that if anybody's interested. It's a pretty cheap way to evaluate your aggregation and what you've got going on out there. So, you know, we want to focus and think about and pay attention to soil structure because of root growth and water infiltration, which leads to increased nutrient cycling and uptake. And it's just a really kick-butt environment for your plants and roots and biology alike. They want that aggregation, they want that space. Okay, moving into water infiltration / percolation. This is going to be a little bit on, the first part of it's going to be how I've used technology to inform a grower about a compaction layer that they kind of suspected but they didn't know, using our soil moisture probes. Most everybody, I've used one of those on at some point in working with you. So you're familiar with them or you maybe heard about them before. But of course, we want to capture every water drop, right? Everything, and utilize it to the absolute best efficiency that we can. This can result in irrigation savings. Greatly reduces the chance of a compaction layer formation with infiltration. Also, irrigating to the same depth every time can and will create a compaction layer. It's that boom, boom, boom. That sort of process is hitting it all the time will create a compaction layer. We all want a bigger pond to pull from, right? Do we want a kiddie pool or do we want Lake Erie? I think Lake Erie. You've got, for the purpose of water as well as nutrients, you got good infiltration due to structure, which is giving you that good healthy balance within your soil. You've got root interception and mass flow and diffusion that are part of your nutrient uptake that plants and your biology and enzymes and everything work with. So some of your nutrients, particularly part of FOS, is not just mycorrhizal fungi. It is literally diffusion is phosphorus and potassium. So we greatly reduce our chances of runoff. And then because where's your most fertile soil? Top 4, top 6, 8 inches. That's going to be the stuff that runs off if we've got a full profile and then get a rain event, if we're not percolating through. And then that air-water balance again, hitting on balance, reducing, eliminating compaction, and maximize your biological activity in life. And then we want to reduce our wetting drying periods. We want it sponge-like. That's all nutrient in your biology. They don't want to be hot and dry. None of us like hot and dry. Super wet soil, now you got bigger problems going on. Balance. So moving, I think my next, Okay, how do we know if we're infiltrating water adequately? Can you spot a compaction layer from above ground? Sometimes you can, sometimes you can't. Plants are really, really good at adapting to their environment. What does your ground look like after a big rain event? Is it shiny or is it dull? If it's shiny, we've got water sitting on top. Probably not the best thing. How does it feel when you use or dig with a shovel or use a hand probe? You have certain spots where it's really tough, you gotta put some oomph into it, or just some places where it just goes right through. With all the soil sampling I do for some of you, when we're using a shovel or a hand probe, Zach and I are constantly going back and forth of, oh, that was really hard, or that was really easy. Is your water agronomist constantly telling you water isn't moving past a certain depth? That's where the probe comes into play. And does it seem like watering never ends? Constantly watering, 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 no matter what. So using technology, I hesitated using this to begin with, and I changed my mind because I did have a couple of blurbs. Probes are not perfect. Anybody that's had one knows that. I have a love-hate relationship. I love the data, I hate the hardware. So ignore that little down there. But this grower, it's a Brown County. I don't know a lot of the history on it. Zach put this probe in, so I wasn't out there. I'm just sending the guy his reports every week. And I kept saying, increase your water, increase your water. Your water's only hitting X depth. It's only getting to 6 inches, or it's only getting to 10 inches. And finally, after a handful of irrigations or rain events, one of my reports, I'm like, dude, you got a compaction layer or something. Like, I don't know what the heck is going on. He immediately calls after I sent the email and said, yep. I kind of suspected that after I seen it in a couple other spots, not anywhere close to your probe, but I've got it on the list for so-and-so to go ahead and deep rip it this fall. By the way, that used to be a gravity field. I'm like, oh, well, that would have been handy to know. But didn't change my recommendations at the time, but it changed our plans through the rest of the season. So, you know, how did I see that? I could see here, so top line 6 inches, 2 inches, 6 inches, and then 10. And notice how all of those spikes, which we know most of that, particularly after July 3rd or 10th there when we had that funkiness of the probe being wonky, that those were pretty much all irrigations. There's hardly any spiking at 10 inches. So it's like somewhere between 6 and 10 inches, you have a compaction layer. Something is going on. Why? No matter. You told me after those first few reports that you were increasing the water, and I could see your spikes got pretty good size there. But what the heck? We're not pushing. You're not hurting, because going back to his profile, he's got a good profile of water. Where the green and the blue line meet is a full point, so the cup is full, and then where the red and the green meet is 25% leeway, so we've drank down 75% of the cup. We got 25% left over. So he's hanging out in good moisture on that 3-foot profile. For sure the 3-foot did pretty good on the top foot, which is that second graph, top 14 inches. But yeah, nothing's moving down. And I saved a slide. I didn't even do the bottom foot because the bottom foot looks exactly like this. He never got water past 10 inches. Definitely very little hit 10 inches. Most of it stayed in the top 6 inches. So now that changes how we manage water the rest of the season out there. Plants look great. I went out there, I think the end of July, first part of August to check something. I don't remember what happened. Looked phenomenal. I think it yielded amazing, but we had to course correct because of that. So hopefully his custom person got the deep ripping done, and we don't have that problem this year. But something I challenge everybody, and we are been using this terminology more: plant demand irrigation management. Use of soil moisture probes, right there in the name, soil moisture. We've always been thinking about and taught and educated on managing your soil moisture. What about the plant? So how are you making your irrigation plans and decisions? What's most important to you as you make those plans and decisions? Amount or timing? I'll get trigger happy. Amount or timing? Where's your water going? To what depth? And how much of it? Amount actually going in the soil profile, that infiltration part. How much water are your plants using? You just going off of ET? Something we do have local ET data, but every genetic is different. Today's genetics versus 20 years ago genetics versus 5 years ago genetics. Seed corn side of things, in 5 years genetics have changed a lot. Where are they pulling water from? When are they using water? Do we think it's sun up to sundown? During the cool part of the day, does it shut down at 4 o'clock? Does it shut down at 2 o'clock? Does it not start till 10? Goes till 6? and my plant genetics, drought-loving hybrids will be stressed if you overwater them and if you water them at the wrong time. Had a drought, one of our drought corn on a grower in Brown County a few years ago, would have been 2021. It was 2021, we were still wet coming out of 2020, or wetter, until we hit like 4th of July, and then we went bone dry, more or less. He had a drought hybrid out there. We had Soil Probe, been working with him on Soil Probe for a couple years. He was comfortable with it. 4th of July-ish hit, first week of July hit, everybody started firing up. He's freaking out. I'm gonna water. I'm like, let me pull up your probe, let's see how things are looking. Plant demand irrigation, remember, right? That's what okay, you did tell me that's what we're working towards, yep. So, roots are rocking and rolling. He's got roots 2 foot down, they're still pulling really good at 2 and 6 inches. Loving life. I said, I think if you water, you're gonna freak something out. You're gonna cause some problems. But everybody else is firing up around me. My brother says we're gonna be harvesting corn in August because it's gonna dry up. I'm like, well then I guess I'll be buying dry corn from you in August. And you don't have to worry about waiting for the combine to get there in October, November then. So let's just see what happens. If you trust me, you've trusted the probe the last 3 years, let's stay the course. When things slow down, that plant will tell us when it wants water. So, plant genetics is key and critical to know. Also, corn plants can pull water from the air as low as 15% humidity. Crazy. They can supplement from the air. How do we put a price on plant demand management? How do we do plant demand irrigation? And is it about water savings for you? Is it irrigation cost savings, nitrogen, yield increase? I'd say for everybody it's all of the above, right? We don't want to hurt yield. We definitely don't want higher irrigation costs. We know things going on across the state with water and nitrogen. Had a little chat with Middle Niobrara this afternoon, those guys up there, and the things that our governor is doing and wants to do, right, wrong, or indifferent. Water and nitrates. We've all been hearing about it. With using probes, so this is my little bit of a sales pitch on probes, and I'm biased. I think every pivot, and every pivot especially, and probably every irrigation, even though we can't quite figure out the gravity side of it, where to place the probe, but every pivot should have a probe, because I guarantee you, at the very least, I can save you the beginning of an irrigation pass at the beginning and the end of the season. We can also, part of that is your irrigation costs, so your energy of running that pivot around, no matter what your energy source is. Then your pivot wear and tear. I don't know what everybody uses for a number that they budget, 5,000, 10,000. Everybody's different, I'm sure. That's all part of it. Some of that's just gonna be a part of it no matter what, but pivots getting stuck is a thing that's a frustration. Where can we save on nitrogen costs as well? With the probes that I work with, we can track salinity. Salinity, salt, kind of not a true direct correlation to nitrogen, but very similar. High salt fertilizer is what majority of people are putting on for irrigation. We don't know exact amount, but there's a pattern. And then we can tell if it's plant uptake or if it's leaching based on root activity and where your active roots are. And then, are we watching and are we looking at stressful times and what's causing those stressful times? How do we evaluate that? How do we be proactive and reactive with those? So, some quick math. On a 130-acre pivot is what I use. So first year probes are $1,600, and then years 2 and beyond it's $1,200. So that math, 1,600 divided by 130 is $12.30 in year 1, and then year 2 is $9.23 per acre. So this is how my brain works in math. Using a well pivot in Brown County with electric motor, but not on the irrigation district, so we don't have that added cost in there. Rough math on an average of 60 hundredths per pass, so again, going back to that 2 passes that I can save you, beginning and the end, $620 comes up to $4.80 an acre. Then in 2014, UNL did a study on water application and its effects on nitrogen. The other software company that I used to work with partnered with them on this because of the salinity portion, and they did a lot of actual nitrogen testing for this. They said every inch over applied loses you 8 pounds of nitrogen. So using that same 60/100, 2 passes, 1.2 inches is 9.6 pounds at 54 cents a pound nitrate commercial fertilizer, $5.18. Right away, just 2 passes and 10 pounds of nitrogen, $10 an acre. And I said, first year probe, $12.30. Now I know I can save you more than 2 passes, as long as Mother Nature doesn't completely screw us over, but even then, it's easy to do that math and make that up. And then how do we put a dollar on not having stressful days, meaning we're maximizing and going hardcore with our photosynthesis. We have adequate carbon cycling, other nutrient cycling because we're not creating anaerobic conditions or flushing nutrients through the system, particularly nitrogen, and that reduced plant stress aside from the photosynthesis. Can we put a dollar on that? Some tips, even without a probe, evaluate your soil structure and if there's any compaction layers. Know your plant genetics and their water requirements, both timing and amount, timing versus amount. Have a way to track your active root zone, and don't keep your soil profile at or above field capacity. It's just keeping your coffee cup full and overflowing. Excess irrigation costs, you don't get to capitalize on rain events, leaching, denitrification, anaerobic conditions. Something in doing a little bit of research, we don't do a lot of water samples up here, and I'd like to do more of that. Midwest Labs does that, but it gets tricky because you got to have that sample down there in 24 hours, I think for all water. They don't want something sitting around. But if we've got over east in Knox County, they have high calcium, and if back in my start of my precision ag days over there, we grid sample a full 160 acre field. They didn't farm the corners, or maybe they did dry land, but their pivot corners would be super low pH, but underneath the pivot would be perfect or even high pH. They're pumping so much calcium out that they're affecting their stuff that way. So if we got high bicarbonate water, that's going to affect nutrient availability, herbicides, everything else too. So maybe consider pulling a water sample, plus then knowing what you've got for nitrates too. There's some test wells that the NRD has, but not every well. And again, timing versus amount. Which one is most important to you? Okay. What are things that we've been taught or been told? We've maybe heard or you've been told that high yielding areas need more fertilizer, or less yielding areas need less fertilizer, right? We've been told that, we've heard that before. So your high yielding areas are actually related to your soils that are cycling nutrients better and faster. We need to know why. What's going on out there? Why are they cycling better and faster? Apply fertilizer to raise your soil test part per million values. More part per million means more available to the plant. Just heard this one on Monday with a grower, with an ag retailer. And I'm like, oh, for the love of God, you are clearly selling fertilizer. That's not how it works. Fight ensued. Focus on NPK, then move into your microbes. You heard that one? If your NPK ain't right, your micros don't matter. So focus on them first before the micros. Kind of. We'll chat on that a little bit. More fertilizer equals more yield, right? Pour the coals to it. Fertilizer we apply will be available to the crop. Ooh. Did you know that roughly only 20 to 30% of those fertilizer nutrients actually make it to and in the crop. What's happening to the other 70 to 80%? And then apply lime and calcium to improve your soil, low soil pH. We've all heard that one up here. So, what are you seeing on your farm? Are soil test values staying relatively the same, even with consistent fertilizer applications? Have yields plateaued, maybe even declined, especially in wacky weather years? Is your plant health in general kind of going down the drain? Are you seeing more diseases? Are you considering more use of more fungicides and hearing more talk of fungicides? Every seed meeting I go to, we get hammered with use fungicide. And I'm like, why? What are we doing so wrong that we gotta put a fungicide out there? Why are you not breeding something that can handle diseases and fungus better? They don't like that question. Herbicides not working like they used to? Okay then. Soil biology is your cow, plus your food source, your energy, your sugars, and apologize for the 45. Cat probably stepped on my computer. They like to do that. Equals your enzymes. These release your nutrients that we want. So the nutrients, are they plant nutrients, soil nutrients, or both? We're going to go over carbon, pH, nitrogen, phos, and potassium. Didn't think of carbon as a nutrient, right? So we've seen this, or a version of this barrel. It's the lowest stave is your yield limiting factor, no matter what the nutrient is. How about this, which is tough to see, I apologize, but it says carbon biology, nutrients, hormones, photosynthesis, plant health, exudation, soil health. What's the minimum stave in that category of those there? So carbon, over the last 150 years, we've lost 30 to 70% in our soils to the atmosphere. Roughly 30% of the world's cropland has been abandoned in the last 40 years due to the decline of that soil quality related to the loss of carbon. Carbon is a gas, liquid, and solid. It drives everything, period, no matter what. And yeah, organic matter is important, but it takes 10,000 pounds of carbon to increase 1%. And then organic matter should be considered your savings account. We don't want to be using our savings account for everyday expenses, right? It's supposed to be the slush fund, the rainy day, in case an emergency happens or we've got to tap into it for a little help. That's what organic matter should be. Organic carbon can hold 4 and 20 times its weight in water. How they came up with those numbers, I have no idea. Somebody smarter and more time and money than me, but that's the stat. So organic carbon, how do we build it? Roots, just roots. Get them deeper, get them more extensive. So those root exudates, as many living plants and living roots as long as possible all year, every year. Improve your nitrogen management through rate and timing. That has to do with your carbon to nitrogen ratio. Your microbial populations all consume carbon. So we got to make it more available by breaking down organic matter to make water extractable organic carbon, WEOC. That's your crop and your plant rotation. Legumes, soybeans are the highest users of carbon. I think it's for every pound of nitrogen, for every pound of nitrogen that soybean plants need, they need 5 pounds of carbon. Remember I commented about carbon and compaction? Anybody gone and stuck a shovel in an alfalfa field or soil sample in an alfalfa field? How hard is that? It's not because of the traffic of it being hayed and baled all the time. The legumes are sucking up all that carbon. So don't waste it, and we want to increase photosynthesis. Okay, nitrogen. Do you consider nitrogen a friend or a foe? We've all seen the nitrogen cycle at some form or fashion, some nitrogen fertigation class. Nitrogen is critical for nutrient for building blocks of plant proteins, growth and development of tissues and cells, aids in the genetics and genetic expression, chlorophyll for photosynthesis, and its energy transfer nutrient. Timing is just as important as amount, which I would say everybody is pretty good and pretty well versed at that. The system is wanting and needing balance. So some issues with excess nitrogen out there, you have soil acidification, ammonium converts to nitrate, you lose a hydrogen ion, thus acidifying soil over time. It alters microbial activity, increased nitrate availability may increase denitrification rate due to bacteria converting nitrate to a gas. You disrupt plant nutrient balance, slows the uptake of other nutrients, excess plant growth, tillers on corn. Some people like to see them, some people don't. I'm in the category of don't, because I'm like, well, if the plant is throwing this kind of energy into new tissue, why is it not throwing it into building me more kernels? It's going back to that detox, it's trying to get rid of excess, so it will throw out new plant growth. And it can push calcium out of your root zone. Impacts biodiversity of your bacteria. Some will thrive and outcompete others. That's a bad deal. Certain bacteria are bad. So that amino acids and protein thing that we only usually hear so much about in the human nutrition side of things is just as critical in our plants. So you've got your nitrate and your ammonium and the process that goes into play of getting it to the amino, thus the protein source, and the micronutrients that play into each one of those steps. So molybdenum, sulfur, and iron for the first step on the nitrate side, and then magnesium, manganese, and iron on the second step to get you to amino. Then on the ammonium, you have the glutamine synthase, and then you need phos, sulfur, magnesium, manganese, boron, potassium, and zinc for that process. So a majority form that we put on, or that's nitrogen is converted to, is nitrate. What the plant truly desires is protein. 80 to 85% of nitrogen in the plant is protein, and 2 to 5 of that is nitrate and ammonium, and we want to keep it to that level. What happens if we get too much? Again, it's stress. There's no exudation, no other nutrient uptake going on. But don't forget about the micros. Your molybdenum is critical for nitrogen fixation. Sulfur is part of creating amino acids. We almost always put some type of sulfur with our nitrogen out here, which is great. And then calcium, manganese, phosphorus are all part of that too. So how do we manage it? Increase our carbon, extractable carbon specifically. Excess nitrate will lose carbon. Back to that carbon to nitrogen. If 20 pounds of nitrogen are ate on by the biology, they will go and find 100 pounds because they need to balance their gut. If they die off, they release CO2. You lose that nitrogen. If they are not in balance, if they're suffocated, they die. It's not like that little bug then gets you fertilizer and you're like, oh, okay, win-win for me no matter what. No. You're done. You lost that nitrogen. It's converted to carbon, CO2. Excess carbon converts to organic nitrogen, which is a good thing. It's the most stable nitrogen form because that then will move into amino acids and protein for the plant use because it's living in that biology. Results in less energy expenditure and less dollars out of your pocket. All something that we want to hear. This is, I'll try to buzz through it super duper fast. So this company, BW Fusion, had done this study of corn and the form of nitrogen at the different stages that a corn plant wants and prefers and takes up. So the first part of the growing season, it wants primarily NO3, that nitrate, which is not a problem at all. We've got our starter, maybe we did a dry spread, we've got starter fertigation happening. And then we get into tassel and reproduction stages. Those those plants are focused on that ear and those kernels and rocking and rolling on that. They're not wanting to put the energy in and out through the root system for that conversion process. So that's when we need to be focusing on, do we have the amino and the proteins out there, or can we apply them? And there are products on the market of amino acids, and getting that process going, because it's fun to focus that energy on the reproduction side of things. You're not growing any more leaves after tassel, right? We're maxed out. So it was kind of interesting in learning about this and getting educated on it, and just why we know how part of why we know how critical not having a hailstorm after tassel is. We're already reducing our energy expenditure out the roots. Now you take off even more of it if we have hail. It's just a double-edged sword. So plants, they don't have inflammation like you and me. So that's all part of that stress and energy expenditure of things that are going on. So the amino acids are stress relief for the plant. Okay, whenever you apply nitrogen, put a carbon with it. Absolutely, if you positively can, because you burn up carbon. So there's humic and fulvic acids out there, literally sugar, and I don't know if I would go and get like your feed store molasses, but if you wanted to dabble with it, you could. The first time I heard about sugar going on soybeans was when I was at Brunswick, and I thought the guy was crazy, but they said that it worked, and now I understand why. So a customer had me go to Sam's Club and get a couple of big baking bags of sugar, and he did a solution in his pivot tank and put it on soybeans. I was like, okay, you're crazy. Well, now I know what he's doing. Pumping carbon back in. Track the nitrogen the plant is consuming and taking up. And then consider including moly with your nitrogen and sulfur passes. I'm not 100% sure. There are different products, particularly that BW Fusion that I work with. I think they've got some moly products that would be interesting to try. So excess nitrates, ammonium in the plant will increase those diseases and insect pressure. Tar spot is oxidized manganese in the leaf due to high heat, nitrates, and salts from your commercial fertilizer. They cannot replicate and grow tar spot in the lab to test fungicides on it. And I asked the UNL guru a year ago, I said, well, that's because it's oxidized manganese, not a true fungus. Oh no, it's a fungus. I'm like, well, you've got data that you don't, but there's no fungicides that are working on it. Like, what do you mean? Another battle ensued. So inorganic versus organic, both are plant available. Organic is your amino acids and your proteins. And then your inorganic is your nitrate and your ammonium. Which two can we lose due to environmental things? Nitrate and ammonium, right? We want things in organic form as much as possible. Your carbon to nitrogen ratio, carbon's your brown material, nitrogen is green. If you have a low carbon to nitrogen ratio, you will, that generally indicates a higher availability of nitrogen compared to carbon. You will have higher decomp rates and more mineralization of your organic matter. And every pound of nitrogen that you will apply will most likely be available because hardly any of it's tied up. High carbon to nitrogen, you'll have higher portion of carbon compared to nitrogen, slower decomp rate and mineralization, limited nutrient availability, especially nitrogen, and you can store more nitrogen, but you will have to apply more upfront. Biology has its own C/N ratio, 3 to 5 on bacteria and 25 to 30 to 1. And that for every pound of N it picks up, it has to have 5 pounds of carbon to balance. Okay, pH. Am I rolling too fast or? Okay. I'm trying to talk somewhat fast, but. Okay, back in a little history on pH. As we know it in the category of nutrient availability, because obviously it is not a true nutrient. Back in the 1910s, 1920s, only 2 things were able to be measured in our soils, temperature and pH. Agronomists for Virginia developed that scale, 0 to 14, 7 being neutral, in 1936. And then we don't hear anything about pH until the 50s. I've heard this one, and maybe idiot might be a strong word, but you're an idiot if you don't pay attention to and address pH with lime, particularly on the low side. Obviously, we have options on the high side. The whole scale is based on assumptions. They saw symptoms of a certain nutrient deficiency, took a pH measurement, and then went, oh, this nutrient is deficient because it's at this pH. And that's how they developed the, which I'll show it here in a second, nutrient availability some picture graph that we've all seen before. A Wisconsin professor in 42 said, yep, that's accurate, let's roll with it, good to go. Published across the globe. Now everybody uses it. Fast forward, I think into either the late 1990s or early 2000s. Summary of that is they never calibrated on different soils when they did their pH. This data is qualitative, it's not correlated or quantitative. There's zero statistical data. It's what he felt like was happening based on observations. Oh, then in 23, a researcher took a deep dive. Soil is so dynamic, it can't possibly ever be simplified into something as easy as a 2D chart, which is this one that we've all seen before. And something. That's why everybody's like, well, we kind of want that like 6.2 to 6.5, because if you roll down, that's about where most everything is most available, right? Yeah, not so much. Okay, this is where it's going to get somewhat fast and deep, and my apologies up front. pH is the concentration of hydrogen, right? Or is it the exchange of electrons? Soil, or chemistry, high school, I did not take chemistry. How do we care, why do we care about pH? It doesn't regulate nutrient solubility, it regulates nutrient availability. Where does it come from? It comes from your parent material, God-given, what we have right here. So what affects it? Your biological and your chemical weathering, water, soil texture, activity, and your biological activity. And your management affects the biological and the chemical side of it. So for example, anhydrous applied injects hydrogen, it precipitates out calcite, which gives you acidic soils. Plants will also release a hydrogen ion to maintain balance in that root zone. Your AMS and elemental sulfur do the same thing, which I don't know of anybody that applies elemental sulfur around here. It takes like 4 months to kick in. Temperature affects your pH as well. It's a resonance that creates vibration more and more. The ions get excited, the bond gets weaker and weaker. Literally, particles break apart. The water flow affects your chemical weathering as well. Length of saturation, again, infiltration, percolation. Biological weathering, that dynamic movement of your pH, essential output of your enzyme function. How does enzyme functions work? Specific structure for each enzyme. Your structure is regulated by the polarity based upon the solution pH. So, this Pac-Man analogy. I got my Pac-Mans, and I got my little dudes. So, your enzyme is the Pac-Man, right? He goes around in the game and he's eating triangles or these little dudes, depending on the version that you've got. And so for this example, he's going to be our phosphatase enzyme. We're going after phosphorus. The triangle is headed towards the Pac-Man, right here, and it's organically tied up phosphorus. It's not going to change. It's not going to do nothing. It's sitting here as it is, organically tied up. Different pH will affect the Pac-Man's mouth. So maybe his teeth are round, or maybe his teeth are sharp, or his jaw opens up more, and he can get around this, because this doesn't change. But this enzyme, that's what you're going after. That's what that different pH environment changes what this enzyme looks like in its mouthpiece of what it can do. So I thought that this guy would be bigger when I bought these. That ain't gonna fit, but you get the gist, right? Both are coexisting. Microbes are creating enzymes. Enzymes don't have any efficacy to break down the compound. So, just as a fun little thing there, that's what pH does, is it affects the mouthpiece of that enzyme for breaking down your nutrient. So, like I said, it maybe opens up more, or it doesn't open up as much. It's all about that Pac-Man mouth. So, it's not about having more nutrient present, a certain one, or available. We're needing to improve the enzymatic function. Essential plant nutrients, with that, going back to, is the exchange of electrons. So it takes up a positive ion, it has to give up a positive ion, usually hydrogen. That's that comment around the root zone. The hydroxyl groups, they bind your calcite material, creating calcium hydroxide, raising your pH. UAN is actually a pretty decent, good, it won't affect your pH. Plants will because plants will take it up. It doesn't have to do that conversion process of anything. And UAN, in the webinar that I watched, will help increase your pH. MAP, monoammonium phosphate, will acidify soils and cause phosphorus degradation. Ammonium, because of that ion exchange, electron. So putting a bow on pH, we care about nutrient availability, and pH does not determine that. It's the enzyme. Microbial activity gets us the enzyme. How do we get that? More carbon. Biggest thing to consider, yes, pH is important. I'm not trying to say that, but if your pH is right and it's sitting in good shape, and we need to know, and if carbon is out of whack and the enzyme and the biological activity is out of whack, your pH isn't going to matter. So, again, not saying that it's wholly wrong. Phosphatase enzyme, they have discovered, loves 5 to 5.5 pH. If you go back to that chart, it says phosphorus is optimal at 6.5. I found super interesting as well. So again, it does matter. And if you're off the deep end one way or the other, we got to work on pH, no doubt. A 4 pH, we're going to have some crazy enzymes going on, some crazy looking enzymes that are not going to work right and do the things the right way. We definitely have to address that. But we need to measure and track enzymatic function as well. So, to a point, can you save your lime application? Can we make other management changes that affect your pH sooner and faster and cheaper than lime applications? And then look at lime as an addition of calcium to your system, not altering your pH. Because plants need calcium. Calcium is the driver of all your nutrients. Oh, I didn't realize I had that in there twice. Okay, phosphorus is the popular kid at school. Everybody wants to hang out with phosphorus. It's rare, it only occurs in certain kinds of rocks and in decaying organic matter. Highly reactive, as soon as there's any free P in the soil, it becomes fixed, including your fertilizer that you put on. It becomes chemically bonded with any other element, with another element like aluminum or calcium, thus unavailable to plant. That's why it's the popular kid in school. Wants to hang out with everybody. Everybody wants to hang out with it. Certain bacteria produce that phosphatase enzyme. Once released, how does it get to the plant then? Mycorrhizal fungi. 80% of your phos is due to mycorrhizal fungi. Ammonium ions increase the uptake of P. Nitrate decreases P uptake. Phosphates depress the uptake of zinc and copper. That one blew my mind because we put zinc in with a good chunk of our starter fertilizers. I haven't quite figured out how to explain that one yet, but the info says that. So something to just think about. Potassium is a tricky one. There's not a lot of info on potassium. Not a lot of research. So we're just going to keep it kind of simple. It's important for carb metabolisms. regulates your water utilization through the stomata on the leaves. It's your coolant or your antifreeze, depending on the crop that you've got out there. Disease resistance, we know that, and that's because of the metabolism of sugars to the carbs. It is mobile in the plant. Deficiency will bring pests and diseases due to increased sugars in the leaves and the roots. Again, there's not a lot of info on soil and plant test levels and disease defenses out there. We know that it has to do with disease resistance, but they don't know how, and they don't have any insight as to what kind of soil levels that you need to have to increase or that decreases that stuff out there. It's kind of like, we know we need vitamin C, but we don't know exactly how it works all the time. Or, pick your other human analogy in there. It's most affected by compacted soils. It can become trapped or fixed in between clay layers. So if you've got that tile floor, the potassium will hang out. That's going to be your glue in between all your layers of your tile floor. So if you got compacted soils, you've got potassium getting tied up and hold up there. Potassium and magnesium can interfere with each other in plant uptake. So, again, that was kind of an interesting one because we do apply a lot of magnesium with calcium, or with potassium, excuse me. So that one was a tricky one for me to try and dig forward. And again, there's just not a lot of info. They just say that they've done the research and they interfere with each other. Okay, how do we know we're on the right track? First, we need a baseline with our soils and our plants. A little, of course, my opinion, and you don't know what you don't know, and now I know better and I know different. Conventional soil tests and analysis versus what's out there, the Haney soil test. The conventional only shows minerals that are passively available. And that has to do with the chemical extraction process that our conventional soil tests and the labs use to extract those nutrients. It's harsh. The Haney soil test uses acids that the plant exudates and the sugars that they do, and then water. So we get an actual look of what the plant sees with the Haney soil test versus the conventional. The conventional is harsher. 97% of your minerals are made available from your microbes. So what nutrients are your plants seeing? This is, I really like this. This is your nutrient pool. So you have a whole pool, and in this example that they were talking about was phosphorus. I don't know where these guys pulled it from, but they had 1,250 pounds in the whole pool, because there's a test out there that we have access to that will give you the full picture. What does the bank have sitting in its vault right now? That's your total pool. You can't access it, but it's there. You got it. Your extractable pool, then, that's your checking account. Then your plant available, that's your daily limit on your debit card. So you've got three different things. The plant available versus extractable. Your extractable is your soil samples in that. And then your plant available, what is the plant seeing? What is the plant gathering and getting? We've all seen one of these. This is a conventional pulled Rock County corn pivot, mid-July in 2022. We've seen these numbers before in some form or fashion. We always look at pH. We like seeing organic matter. It's mid-July, so we pulled these samples because we wanted to know where we were sitting at for nitrates in total pounds. Here we are. Everybody's got some sort of sample like this. So do certain part per million levels equate to certain or exact pounds of nutrient? No, they don't. What about certain pounds that are plant available? What forms are these nutrients in? And how much fertilizer to raise a soil test value by 1 part per million? Phosphorus, industry says, the gurus out there, 20 pounds of P2O5 to raise 1 part per million on your soil sample. So, say you want to raise phosphorus to just 50 part per million from the soil sample, and we're gonna use the top field. So 50 minus 16, we got 34 more part per million times 20 pounds, 680 pounds of P2O5. MAP is 50%, 52% P2O5, do your math, so 1,300 pounds of MAP just to raise it to 50 part per million. At $800 a ton, $522 an acre. And then you get 143 pounds of nitrogen in the ammonium form. And 50 part per million is a low number from what my interaction on Monday was with the ag retailer for what he wanted to see phosphorus part per million move to. I did the math on potassium too, if anybody's curious on that, but I don't have that here, I have that in my notes. Mind blowing. Not very cost efficient to do things by part per million, because there's no insight on that part per million is this many pounds that are going to be plant available. We just know if it's high or low. Okay, in what form? This is an example of a soil health Haney test. This is from this last summer, first part of July in Rock County. It might have actually been from on that other one 2 years prior on that top field. So we look at, when Zach and I sit down, we look at nitrate. We want to know nitrate, which we get on the other sample. And we want to know total nitrogen part per million with the factored in of the ammonium and the inorganic. We want to know the organic nitrogen to inorganic nitrogen ratio. We want that ratio number. If it's 1 or less, much of the nitrogen present in the soil, that particular soil sample, is nitrate or ammonium, if it's less than 1. So we're just right over that the majority in that soil is nitrate or ammonium. Again, microbes and plants can use this, but it can result in nitrogen immobilization and tie-up, taking nitrogen from your crop. We would like to see that 2 to 3, if not closer to 5. But this also gives us total nitrogen pounds per acre, because it's factoring in your inorganic and your organic, not just nitrate. Again, back on the conventional, all we saw was nitrate. We look at total phos, and then conversion back to actual pounds of phos. So when you see that H3 extract, and then H2O down here towards this left side, that H3 extract is their water with their sugars, the same as your plant root exudate. So there's 50 pounds, and we just did 0 to 8 the first week of July. They received it on the 7th, so we probably pulled it on the 6th or 7th, or the 8th, excuse me. So 50 pounds. That's not bad. We've all seen this little slider before, right? 220 bushel corn. This says you need 84 pounds of phos. Well, of course, this is July, so we don't know what the plant's taken up and utilized already, but 50 pounds to get him through the rest of the season might not be all bad. Of course, we do get a CPH. They don't leave that out, or organic matter. But another one, soil respiration. So your respiration, it's a 24-hour test, and because your soil is aerobic respiration like we are. It's related to biological activity, nutrient cycling, and soil aggregation, organic matter formation, disease suppression, and stimulation of plant growth. High respiration means more microbes are present and greater potential for activity and nitrogen mineralization. We want that number as high as we possibly can. You can change, or it will change each growing season and during the time of year. Cold soils versus warm soils, wet versus dry. Organic carbon, I mentioned earlier, that water extractable organic carbon. WEOC, that is your most readily available food source for your biology. Again, we want that number high. MAC, which is microbial active carbon. How much of the WEOC pool is acted upon by the biology measured as soil respiration. So to make that as If it is below 25%, WEOC is not a limiting factor. Carbon is not a factor in your respiration. We need to look at adding more carbon to the system. Ideally, we want 50 to 75%. This sample's at 12, and it's a Rock County sandy field. So I didn't expect it to be super duper high. We've had, especially that time of year, after the rains through June and then turning hot, which is part of why we pulled this sample for the nitrogen part, but we're gonna start tracking that there. And then getting back to looking at our carbon to nitrogen ratio. Which I did not put my factoids on that, but there's high or low indicates and is factored into that from that organic carbon number and your nitrogen numbers. So going back to a previous slide of is your carbon CN low or high? Are we mineralizing or are we not? Are we tying things up? This also gives us a full-blown math and what math they use for their fertilizer, but it's just really cool because if you factor in, you have so much more than just nitrate, nitrogen out there. Can we use this 1 or 2 times in season and make and adjust our in-season nitrogen applications? Absolutely, and we do it every year for a handful of people. This is that whole big money in the vault at the bank picture of total nutrient digestion. 24,000 pounds of carbon, 25,000 pounds of nitrogen. Again, it's what's out there. Can we get a plant available? Can we get it cycling through the system to make use of it? Now we got more questions to ask, but here's a crap ton of nutrients out there. What do we need to do to capitalize on it and use them? Okay, here are the slides everybody's been looking for. It's simple. How can we create, sustain, and maintain enough energy throughout the crop's lifespan so plants can tolerate stressful times without giving up part of its life? Having the right nutrient at the right time is critical. Your plants regulate your systems. Farming is 3D, it's not 2D. You can't focus on just the soil or just the plant. It has to be a full system, and it's not just about one simple product management or a handful of products to manage. So what problems or issues do you have that we can help you solve? Going back again. Let's get proactive instead of reactive, or more proactive instead of all reactive. And how do you know when you can start backing off commercial fertilizer? If that's a goal that you have. Do you have a functioning system with both your plants and your soils? Low commodity prices with a soil and plant system that has been reliant on commercial fertilizer for an extended period of time is not the time to back off. I'm sorry. It takes some time. You maybe can back off a few things a little bit, but I know it's tough. It's a conversation I've had with a lot of people this winter is where can we cut, because $3.50 corn, $4 corn, and $8 beans is not very much fun. Sorry, could have a little bit of a crash on your yields if we back off now. So, but can we do some trials perhaps? Can we take 10 acres or 5 acres someplace and cut back half of nitrogen and see what happens? Again, start with a small area. Yield is cool, I get it, but profitability is key, and it's way cooler. Profitability. It's not about pounds of product applied, it's what is plant available and how are your plants asking for it, and is it the process happening to be planted? So of course, as I mentioned off and on, soil health testing, I haven't used it yet, but I won this in a giveaway. We can look at bacteria to fungi numbers. It's just an app, and we pull a little soil sample and do that. We are going to, like I said, the Brix testing and then sap plant analysis. It is really, really cool and really awesome. It's more accurate information of what's actually happening in our plants versus the old school plant tissue tests that we send in where they burn the leaves and they do all of their crazy extraction. They're using the sap within the plants to give us that information, and we'll be doing that here for 25 and beyond. And of course, if regenerative is intriguing to you, principles and practices or parts of it are, did officially, oh, I didn't do it right, bring that on with a new division of Yield Plus Agronomics called Grow Forward Soils, which that's right there. Soil driven and forward focused. Also got a really cool new weather station locally, right up at our house, because we don't have any local growing degree units up here that are easily accessible. So I'm trying to figure out how to get that into something that can be shared with anybody that's interested in it. If anybody's got any good ideas on that, aside from just a group text, which can get annoying sometimes, let me know. I'm still exploring options for that. But with that, it's a company that really brings in a lot of agronomics, and I am demoing with them crop yield forecasting and predictions. So we'll see how that works, because they're bringing in weather data and solar radiation and all the things. Plus gonna have a bug trap on that for our Western bean cutworm. So we can, instead of me just watching the moths at the seed shed, we can actually have a count every day or every other day on those. We do work with BW Fusion. They have a number of biologicals, micronutrients, humic fulvic acids. Got cover crops and forage seeds, Sentinel fertigation for nitrogen management with your center pivots. Doesn't have to be, they are moving into the dryland world, but I'm really excited about that. When I first heard about it a few years ago, they had a long way to go, and I think they've made those leaps and bounds with that technology and showing some really good promise there. So if anybody's interested in that, it's using satellite imagery from a couple times during the week. We have a canary plot and a high plot, so 30 pounds less or 30 pounds and 30 pounds more of your normal nitrogen, and then it's calibrating the rest of the field off of those high and lows to give you, in 5 days you're going to need another 30 pounds, or get another 30 pounds on now, or you can wait a week and see how things are looking. Really cool what they've been doing and growing there. We are doing some trials with another company called SD Biologicals. Their main thing is it's nanotechnology for product enhancement, for driving things into plants, whether it's herbicide, foliars, fertilizers, anything like that. We'll see how that one goes. And then Brent and I, a little over a year ago, put together a Johnson Sioux compost system. So we'll let you know how that fiasco or success goes. But compost teas, it's inoculating with our natural biology. It's liquid bugs from our sources locally. That some people have some hesitations on using biologicals from companies because it's not native or they might not survive here or whatever. A Johnson Sioux compost extract process is using your own local bugs and just exploding them and letting you, we can treat seed with it, we can do in furrow. They have all sorts of, there's different methods to that, but we're gonna be doing some dabbling with that as well. If you need more info, here's a chunk of my sources that I use for information, a couple of books that I really like. If you like podcasts, the Regenerative Ag Podcast with John Kemp. John Kemp is Amish and is an amazing agronomist. He knows so much about agronomy, soil and plant science. It is insane. If the pH thing intrigued you, I got that from the BW podcast, episode 14, and then some other info. Questions, comments, concerns, celebrations? Too much, overwhelmed, underwhelmed. Oh man, I did that just under 2 hours. Holy crap. I thought I was going way over time. What do we think?
Have you ever heard of Glenn Regenberg? I mentioned him the last time I was here. That's like, right when I walked in here, like, that is his thing. Yeah. Like, he's good to listen to as far as, like, resources.
That's probably the reason that sounds familiar is probably because you mentioned it, yeah.
That's,
Because the Ravenburg sounds familiar.
yeah. He has a lot of this, some of this is more stuff that you were discussing.
Yeah.
Really cool.
And it's just, when I was thinking about what do we do for a grower meeting, I mean, of course, wonderful Brent, I'm like, what do you think? You're a grower, what would you like to hear? Or what do you need to hear? What do people need to hear? Thought about getting a soil scientist, the Regen Ag Lab guy, but he charges a pretty penny for coming and speaking, plus mileage. So I'm like, gosh dang, surely between all my info, these kind of resources, and some hair pulling, I can put together something, right? And I know it was a lot, but just the more I've learned, the more it's like, we gotta know these basics. We gotta know how the things that you're doing, how they're working with each other or not working with each other. Like I said, it's not about trying to get you to go one direction or the other direction or us versus them. It's just do what you're gonna do. Let's just get more efficient with it. And let's work with the system that we've got. As you can see, there's surveys on the table. I would greatly appreciate feedback, constructive or deconstructive. I can't do better if I don't know what I did wrong. I will have them come grab and do menus. We'll just order off the menu was my plan. If you want to order drinks, mixed drinks, beers, whatever, help yourself. I don't think I need to put a limit on anybody, but it is a Thursday, and I think it's the first day of spring. If you want to celebrate that you're in out of the wind, or cabin is going good, or whatever.
We drove down on Wednesday night because we were
You get any? No, but I can pass it.
But they want to get 3 or 4 cents.
Oh, I think that was 63.
Got some menus passed out here for you guys. Yep, we've got Mexican for our special, and the ribeye steak dinner is also being featured. Okay, are we doing okay on drinks? Should I bring back some water maybe? Top y'all off? Yeah. There's a menu, that menu. Oh, yeah, there's a separate menu. I'll grab a couple more of those.
What? Me, Lady Leftinger?
Did you go to Highland Center Conference?
We're in Mitchell. I love going to college in Mitchell. I'm trying to think what that was. Was that like, what's his name?
Alan Boyer and the African. Did you go to Highland?
I don't know. I should know that. It's not ringing a bell.
I don't know. Some of the second year rounds get planned.
I'm a first year, so I don't see it anymore. I don't think I did, but.
Yeah, I don't think.
Denson. Where are you
You
from?
drinking tea or water?
Oh, that's true. Really? What's your name? Oh, yeah, I know you. That's so, sorry. Yeah.
Rogers.
I'm Roger's niece. Okay, yeah. I don't know why I recognize I recognize your name though. Okay. Yeah. Alan Hoyt.
No, wrong.
Okay. Was your water there for you?
Well, you just came from school, right?
Yeah. Okay.
Oh,
A little bit.
I'm sure, are you on spring break?
I was last week.
Oh.
The timing just was off.
Okay.
It's alright. It's great.
Yeah, no, great. Bum your dad there.
I know they have that day. That's I just don't like that either. They're trying to catch up to that, but I'll do it.
It's just their higher hand option?
Yeah, and you're in there going your turn.
Oh, okay.
It usually runs about